The increased size makes sense because the fossil record also shows an increase in size. Whew, this is interesting. So, going back to the sequence of fossils, what if we reconstruct a floating forest from it? Just put the Horneophytopsida out there, growing out into the water, the Rhiniopsida out there at the edge, progymnosperms. That's this tree here. It's a progymnosperm tree. Arborescent lycopods would be these funny-shaped trees here. Gymnosperms are some of these intermediate height trees. Cycads and that sort of thing are found a little shorter ones. Chordates is an early in the fossil record pinopsid. And here we have, from the outside to the inside of this floating forest, increasing size and terrestriality. Imagining this thing not as growing out from the land, but imagining it as floating in the ocean. Thus, you have the same thing over here. You're going from sea plants towards the middle in all directions in this increasing size and terrestriality, a floating forest. If that's the case, then, let's see, I don't think this is... It's not quite the order I wanted this in. Sorry about this. I just made this afternoon and I messed up. If there was such a floating forest before the flood, then in the flood, I would expect the flood, when it begins to create large waves and that sort of thing, to begin to destroy this thing from the outside on both edges towards the middle. Thus, it would destroy it from the outside to the inside. It would thus produce this set of fossils down below it. So the stuff would fall down in this kind of an order. That's the basic idea. So now backing up, if that's the case, then when we see in the museums a reconstruction of the plants during the early Devonian, and this is taken off of one of those sites, ignoring the land back here, because there's no evidence for that, this could be, you're looking at the edge, from the edge of the floating forest out to sea, and you're looking at the Rhiniophytopsids and the Horneophytopsids and so on. So whereas in the conventional, sorry, it's getting hot. In the conventional perspective, you're looking at something that's 400 million years old, early in the stage of evolution. I would suggest this is actually a picture of the pre-flood edge of the floating forest, way out here towards the edge. Now the pictures, in contrast, of the coal forests are actually reconstructions of the center of this floating forest, here in the middle. Okay? So the sequence line of plants in the Paleozoic, which goes like this, increase in size and increase in terrestriality, would be explained by this simple hypothesis. Okay, now there's the basic theory, as I originally proposed it. What's exciting about a good theory is that it turns out to be more explanatory than you originally designed it for. Okay? Because I realized that another consequence of this is I would expect that if the flood destroyed this forest, how in the world could the forest ever regrow after the flood? And the rough, especially in the rough post-flood world with lots of catastrophes that are occurring afterwards, there's no way. There's no way this thing could regrow over the oceans. It had to have been created on the oceans. It couldn't regrow. So I would expect that the plants that dominated in this thing would largely be extinct, unable to develop that pre-flood ecosystem once again. So it would explain why almost all the Paleozoic plants are extinct. Virtually all of them. Also, something that's always bugged me, and I really didn't think of it while I was developing the theory as I was going along, is the best fossils here, especially down here in the Rhiniophytopsids and the Horneophytopsids and so on, these are found in marine sediments. They're not found in terrestrial sediments. I can remember it always being explained, well, the plants get washed down to sea, and the sea is the best place to preserve them. which seems somewhat reasonable, but alas, this is much more reasonable to assume that the reason that everything's deposited in marine sediments is because this is a marine ecosystem. These are plants, but they're in the marine realm. They're in the ocean. So this is actually an oceanic ecosystem, not a terrestrial ecosystem, even though it's above water and that sort of thing. It's going to be deposited in marine sediments. Plus, when you get over here to the coal deposits, as you probably know, the coal deposits above and below the coal deposits are marine shales. They're invariably preceded by marine shales. The footbed or the seat bed for coal is almost invariably a marine shale. And there's almost invariably a marine shale above it. And when you have seats in the coal, they've often got marine fossils in them. In fact, the Mazon Creek material, which is one of the best fossil localities in the world, of these little round nodules that break open and got jellyfish and plants and all sorts of things in there. Those are formed in a marine ecosystem and they contain marine fossils. And they're sitting right on top of a coal seam. So the fact that they're found in marine sediments is also then explained by this. But it doesn't stop there. What I didn't know about at the time I proposed this was there had already been some work by a creationist in Germany by the name of Joachim Scheven on specifically the coal, the trees that make up the coal. He observed, well, everybody's observed it down through the years, nobody has known quite what to do with it, that the big trees, those big trees in the reconstructions are all hollow. They're all made of bark. They're 80-foot tall trees, but they're supported by 2 to 3 layers of bark. They're hollow. And the roots, they're not really roots, they're also hollow. Because they're hollow, they're not roots. Okay? They got roots coming away from them. And that goes for the Equisitopsida and for the Phyllocopsida, which are the two, basically the biggest trees in the whole thing. Hollow. And the rootlets coming off of the roots, again I'm using roots in quotes here, are weird too. They're also hollow. And they come away at 90 degrees